Good afternoon. Okay, today I'm going to discuss to you the topic of the module that we had yesterday about air density, or it's also called as atmospheric density. Okay, let me share to you my screen to show you what we had yesterday. Okay, so here's the module that we had yesterday about um, density or atmospheric density. Okay, so the learning objectives for this topic are as follows: discuss the density of air or atmospheric density, explain the relationships of gas density and pressure, discuss the application of gas density, and calculate gas density using atmospheric density equation. So I'm not going to discuss everything because I presume that you have already understood some of the concepts in this module. I'm just going to give emphasis to the air density formula of the atmospheric gas equation, which is a formula of density equals P divided by RT. So the raw sign stands for density. The unit is kilogram per cubic meter. P, air pressure. The unit is Pascal. R is the specific gas constant, which has a value of 287.05 joule per kilogram Kelvin. Okay, temperature, T is for temperature, the unit is Kelvin. So take note of the units used in this formula. So ito dapat yung mga nakikita nating units when we are calculating. So, in an event that, for example, most of the time makikita natin na ang given sa temperature especially is in degrees Celsius. So, you must convert that value to a degree Kelvin by adding 273. So, I indicated in that slide on how to calculate or to convert degrees Celsius to Kelvin. Just add 273 to the value of degrees Celsius. Okay, let's say for example here for AQ number 1, so you have to convert these values to degrees Celsius and to Kelvin and degrees Celsius. Okay, let's for example the given is 100 degrees Celsius. To convert this to Kelvin, just add 273 and we got 373 Kelvin. So as simple as that, how to convert degrees Celsius to Kelvin. Right, so let's have this sample calculation for air density. Here, calculate the density of gas at 25 degrees Celsius and the pressure is 600,000 Pascal absolute. So the first thing that you have to do is to look if there are units that you need to convert. Here, we need to convert the temperature to Kelvin. So I've told you just add 273. And here in this problem, the value of the temperature is 298 Kelvin. So the formula is this one. Density equals P divided by RT. So let's substitute. The value of our pressure is 6,000 Pascal. And our R is 287.05 kilogram Kelvin. So saan natin ito kinuha? Dito natin ito kinuha. That is the specific gas constant for dry air, ito yung value niya. Ito yung gagamitin natin whenever sa problem ay hindi given yung R. Because in each gas, meron sila kasing kanya-kanyang value ng specific gas constant. The density is kilogram per cubic meter. J stands for joule. Okay. So for SAQ2, calculate the density of chlorine gas at 20 degrees Celsius and with a pressure of 6,000 Pascal absolute. Okay, the gas constant for chlorine is given with a value of 117 Kelvin. So dito hindi natin gagamitin yung R ng dry air because given yung or gas constant ng fluid which has a value of 117. Okay, so here's the formula. Density equals pressure divided by RT. Okay, so just follow the formula, substitute, and do the calculation, and you'll be able to get the density. For SAQ3, we're going to refer to the SAQ2. Yung answer dyan ay gagawin nating reference for the calculation of the specific weight. So how to calculate the specific weight? Simply multiply density with the acceleration due to gravity. So this is constant also, di ba? So this we have already encountered this in our previous discussion. Acceleration due to gravity is 9.8 meter per second squared. And then the answer to that, the unit is meter. Yan dapat ang unit na ilalagay ninyo dyan. Calculating the specific weight. Okay, for SAQ4, calculate the specific volume. Okay, remember that specific volume is the reciprocal of the density. So, whatever we computed here in SAQ to the density, gagawin lang natin itong parsa to 1 divided by the computed density. And, ano yung ang unit nito, unit of the specific volume is cubic meter per kilogram. Cubic meter per kilogram. Yun yung magiging unit ng inyong answer. Okay. So, I hope that you will be able to understand, especially sa part na ito na medyo maraming nalito. Understand the concepts, especially dito sa calculation of the air density. So, lagi lang natin tatandaan itong formula ito. And then, if in problem, hindi given yung R, use the specific gas constant of the dry air. Most of the time, ganun yung problem, hindi given yung R. So, you are going to use this 27.05 joule per kilogram Kelvin. Okay. So later on, I'm going to give you activities for you to be able to gain more understanding about the calculation of air density. So I'll give you some exercises and problems para ma-master niyo itong calculation na ito. Okay, that's all for today.